Have you ever wondered how humans will breathe on Mars? Mars, the fourth planet from the Sun, has long been the subject of human fascination. Its reddish hue, visible even from our blue planet, has earned it the nickname, the Red Planet. From ancient astronomers to modern scientists, we've been drawn to it, our curiosity piqued by the question, could we one day call Mars home? In the 21st century, our Martian ambitions have moved beyond mere curiosity. We are now looking at Mars as a potential new frontier for human colonization. Yet turning these ambitions into reality is no small feat. It poses a myriad of challenges, not the least of which is the question of how to provide breathable air for astronauts or settlers. You see, the atmosphere on Mars is vastly different from that on Earth. It's composed of roughly 95% carbon dioxide, with a trace amount of oxygen. Yes, you heard that right, only a trace. This is a far cry from the 21% oxygen that makes up our own atmosphere. In fact, the Martian atmosphere is so thin that if you were standing on the surface of Mars, it would feel like you were at an altitude of 35,000 feet on Earth. That's higher than the peak of Mount Everest, the world's tallest mountain. So you might be wondering, how do we plan to overcome this challenge? How do we transform Mars from a barren, inhospitable planet into a place where humans can breathe freely? What would it take to create a breathable environment on this alien world? The answer is not simple, but it is within our grasp. It lies in an array of innovative technologies and creative solutions, some of which are already being tested as we speak. From splitting atoms to harnessing the Martian atmosphere, from planting the seeds of life to creating artificial habitats, we are exploring a multitude of ways to make Mars breathable. So, how exactly do we plan to overcome this challenge and create a breathable environment on Mars? The answer might lie in a concept you learned in high school chemistry: electrolysis. Now, you may recall that electrolysis is a process that uses electricity to break down compounds into their constituent elements. Often this is done with water, splitting it into hydrogen and oxygen. But what does this have to do with Mars? Well, quite a bit, as it turns out. The Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE for short, is a technology aboard the Perseverance rover that's testing this very process on the Red Planet. You see, MOXIE is essentially a large, high-tech version of the electrolysis experiments you might have done in chemistry class. Instead of a beaker of water and a couple of electrodes, though, MOXIE is a car battery-sized unit that pulls in the thin Martian atmosphere, which is mostly carbon dioxide, and splits it into oxygen and carbon monoxide. Now you might be wondering, why not just split water like we do on Earth? Well, water is scarce on Mars, and what little there is often in the form of ice. But the Martian atmosphere, that's plentiful. And while we can't breathe carbon dioxide, we can certainly breathe oxygen. That's where MOXIE comes in. In its experiments so far, MOXIE has been able to produce about 10 grams of oxygen per hour. That may not seem like a lot, but remember, this is a proof of concept experiment. It's not meant to produce enough oxygen for a human to breathe, but rather to show that it's possible to produce oxygen on Mars at all. The hope is that in the future, larger versions of MOXIE could produce enough oxygen not just for astronauts to breathe, but also to fuel rockets for the return journey to Earth. Imagine that, a gas station on Mars making fuel out of thin air. While promising, electrolysis is not the only method we're considering. But it is a tantalizing glimpse into a future where one day humans might not just visit Mars, but live there. What if we could produce oxygen directly from the Martian atmosphere? It's not a far-fetched question, but rather a critical challenge that scientists are actively working to solve. The atmosphere on Mars is vastly different from ours. It's composed primarily of carbon dioxide with only trace amounts of oxygen. So, how do we transform this carbon dioxide-rich atmosphere into a breathable one? Enter the concept of a reverse fuel cell, an ingenious solution that could hold the key to human survival on Mars. Just as the name suggests, a reverse fuel cell does the exact opposite of what a traditional fuel cell does. Instead of using oxygen to generate electricity, it takes in carbon dioxide and emits oxygen. This is achieved by a process known as electrolysis, where an electric current is passed through a substance to effect a chemical change. In this case, the substance is carbon dioxide, and the desired chemical change is the production of oxygen. The reverse fuel cell is an exciting prospect, but it's not without its challenges. For one, it requires a significant amount of energy to function. This energy could come from solar panels or nuclear power, but these sources come with their own set of challenges in the Martian environment. Moreover, the amount of oxygen produced by a single reverse fuel cell isn't substantial. To sustain a human mission, we'd need a massive array of these cells, a colossal undertaking in itself. And then there's the question of reliability. These cells would need to operate flawlessly for years on end, in an environment that's notoriously harsh and unpredictable. Any failure could be catastrophic, underscoring the need for robust, fail-safe systems. So, while the idea of harnessing the Martian atmosphere to produce oxygen is tantalizing, it's far from being a silver bullet. It's just one part of a multifaceted approach that's needed to make human life on Mars a reality. But even these methods may not be enough for a full-scale human mission. The quest for oxygen on Mars is a complex puzzle, and we're still putting the pieces together. Could the answer to our oxygen problem actually be plants? Now, this might sound a bit outlandish, but bear with me for a moment. We're all familiar with the process of photosynthesis, right? It's that nifty little trick that plants have where they take in carbon dioxide, soak up some sunlight, and exhale a breath of fresh, sweet oxygen. It's a simple, natural, and beautifully elegant solution to our Martian oxygen conundrum. But there's a catch. Mars isn't exactly known for its lush greenery. The red planet is more of a desert, with temperatures that can plunge to -80 degrees Celsius at night. Not exactly a hospitable environment for our green friends. So, how do we overcome this hurdle? Enter the world of advanced botany, where scientists are already experimenting with a new generation of hardy plants, genetically modified to withstand the harsh Martian climate. These plants won't just be for creating oxygen, but also a potential source of food for future Mars dwellers. Imagine a Mars colony, where you can step into a greenhouse, bite into a fresh Martian-grown apple, and breathe in the oxygen produced by the very tree it was plucked from. We're also exploring the idea of terraforming, a process that involves altering the physical conditions of Mars to make it more Earth-like. While highly speculative and far off into the future, it's a tantalizing prospect that could see Mars transformed into a green oasis in the cosmos. Of course, these are just potential solutions. The reality of creating a breathable atmosphere on Mars is a complex challenge that will require a combination of many strategies. But the idea of using plants, the very life forms that have been providing us with oxygen here on Earth for millions of years, is a testament to the ingenious methods we're willing to explore. These are just a few of the ingenious methods we're exploring to provide oxygen on Mars. As we look to the future, the question remains, can we create a sustainable oxygen supply on Mars? The answer is not as far-fetched as it might once have seemed. We've already discussed some of the promising methods under development, including electrolysis, harnessing the Martian atmosphere, and using plants. Each of these approaches offers a unique set of benefits and challenges, and ongoing research continues to refine and improve upon them. Electrolysis, the process of using electricity to split water into hydrogen and oxygen, is one of the most promising methods. It doesn't require any raw materials from Earth, which makes it a potentially sustainable option. However, it does require a significant amount of energy. This is one of the biggest challenges that scientists are working to overcome. Harnessing the Martian atmosphere is another viable option. Mars's atmosphere is made up of about 95% carbon dioxide, which can be converted into oxygen using chemical reactions. But, similar to electrolysis, this process also requires a lot of energy. In addition, it would require machinery that can withstand the harsh Martian conditions. The concept of using plants to produce oxygen is perhaps the most fascinating. Plants naturally produce oxygen as a byproduct of photosynthesis. The idea is to create a biosphere, or a closed ecological system, within which plants could thrive and produce the necessary oxygen. This method, however, is not without its challenges. It would require a controlled environment, and the plants would need to be protected from Mars's extreme temperatures and radiation. These methods are not mutually exclusive, and it's likely that a combination of them will be used to create a sustainable oxygen supply on Mars. The dream of humans breathing on the red planet is not just a sci-fi fantasy anymore. It's a goal that scientists and researchers around the world are working tirelessly to achieve. As we continue to innovate and explore, the dream of breathing on Mars moves ever closer to becoming a reality.